This is Planck's constant experiment. Here we are going to calculate what's the Planck's constant value. Right? This is a circuit diagram of Planck's constant. This is the source. Just to connect source to circuit. And here voltmeter, and here this is positive terminal to positive terminal and negative terminal to negative terminal, and this is LED plug, and we need to plug in so different colors. Show me the tabular column. So, see, to calculate Planck's constant, so this is a formula, E by C times lambda into V average. So what is the lambda V in the sense? This is wavelength of the light, and this is new voltage. When the LED is plugged in circuit, how much voltage is dropped between that LED? So that we call it as a new voltage, and we need to find out lambda times V average. If you substitute in this, you can calculate Planck's constant. You see here that E is charge of electron and C is the velocity of the light. So how can we calculate lambda V average? Now let us see this tabular column. Here color blue, and this is a wavelength, and we need to find out what is the knee voltage. If you multiply lambda and V voltage, we will get V lambda, and if you calculate average, we will get average of lambda V, and you substitute in this formula, you can get the Planck's constant. So next, in this experiment, we are going to find out what is the wavelength of IR also. So IR in the sense, it's infrared. So here the wavelength of the infrared is equal to, so lambda V average by, so this is voltage when the IR LED is plugged in the circuit. Let's see. So first you have to plug in LED and just to switch on. See this is a blue LED, and see the voltage. You see 3.63. You have to note it down. So the here blue, this is its wavelength, and we need to write down this voltage. So next we just to switch off and plug out this and plug in another bulb. Switch on. You say this is a red light, and here the red light wavelength is given, and see this is a voltage. Next switch off it and take out this light and plug in another LED. And see this is orange, and see this is new voltage orange, and we have to note it down, and then switch it off and plug out and plug in another bulb. So this is a green, and you see the new voltage of the green LED bulb. So here, what is the relation between this light to this voltage in the sense? So energy of the green light is less when you compare with the blue. So to glow this light, it's required some energy that is equal to EV. So E is a electron charge and V is a voltage. That's a voltage we are calculating over here. This is green light. We just write it down what is the new voltage and just plug out. Next, so another one, you plug out another bulb, and see we are not able to see any light because of this is IR rays, IR LED. So this is a voltage where the IR bulb, this is when the IR bulb is plugged in circuit, and this is the new voltage. So you write down here. So IR light wavelength that going to be determined, and this is new voltage is 1.29, right? So we got all the values. We got new voltages and lambda. You just multiply and you get lambda V, and you'll get 4 values and add them up, divided by 4, you'll get average value. Right? So once you get the average, you just substitute in this formula and substitute E value and C value, we can calculate Planck's constant value. And to determine wavelength of the IR LED, the same formula has to be used. So here, wavelength of IR rays, and here lambda V average that we have calculated from here, VRI. So you just substitute in this and we can get the wavelength of IR LED.